Okay. I and the author will, along the way, assume that some of you guys know graphs of what we consider some basic functions. Okay. The Board of Regents also says we, as college algebra students, have to be able to recognize some basic graphs of basic functions. So something we've already talked about now is the equation of a line. Okay, so if I want to graph the line y equals x, we know that's a line that has a slope of 1, has a y-intercept of 0, 0. It passes through the origin and looks about like that. Okay. We also need to know some basics about the quadratic function y equals x squared. Y equals x squared is a parabola with a vertex at 0, 0, and opens up. It looks a little rounder than that. And we will spend more time later on getting into more details with quadratic functions. But just the general graph y equals x squared is a parabola that opens up, vertex at 0, 0. Our cubic function, y equals x cubed, has a general shape like this. Some things that we know about functions, some things that along the way I will ask you guys to demonstrate that you know to me. We've talked about domain and range of functions and relations in other sections already before today. Okay. If I look at the line y equals x, its domain is going to be all real numbers. Okay. The line that goes to the left forever, it goes to the right forever. Okay, we've also at some point mentioned that with domain, that polynomials have domain, polynomial functions will have a domain of all real numbers. Okay, whether it's x or x squared or x cubed or x to the 47th, there is not going to be any restriction on what we can plug in for x. Okay, all of those graphs will go left forever and they'll go right forever. Okay. Now for the range, not all of them have a range of all real numbers. So let me write the word range out of that. Okay, pause real quick. Okay. With a straight line, however, remember that unless we're dealing with a vertical line or a horizontal line, there are those are the only two exceptions to most of the things that we look at and worry about with lines. So if the line has a positive slope or a negative slope, it's also going to go up and down forever. Okay? Its range and domain are both going to be all real numbers. Okay, here with y equals x squared, it does not go from negative infinity to infinity. The lowest point on the y that it touches is 0. But it does go up forever to infinity. Our cubic function goes down forever, it goes up forever. It touches every real number in the y direction. Okay. Let me extend my page there. Some other functions that we might be asked to recognize. Y equals absolute value of x. Okay. Now, if we're not sure what this looks like, we can plot some points, meaning I can pick a number for x and plug it in and see what comes out for y. If x equals 0, y equals 0. If x equals 1, y equals 1. If x equals 2, y equals 2, and so on in this direction. Okay. But if x equals negative 1, the absolute value of negative 1 is 1. The absolute value of negative 2 is 2, and the absolute value of negative 3 is 3. This is a horrible picture, and I apologize. Oh my. I don't do super great on a tablet. Okay. So our absolute value of x, it's kind of like a line broken in half. We're going to stick it in the ground, but the absolute value of x is going to make a v. If we want to talk domain, of this function, it does touch all real numbers left and right. In the y direction, this one has the lowest point. It's going to be a lot like the parabola. It has a lowest point, but it does not have a highest point. If I want to look at f of x equals square root of x, we looked at x squared up here, but now the square root of x. Again, if I don't know what that looks like, I can pick some numbers for x and plug in and see what comes out for y. If x equals 0, the square root of 0 is 0. If x equals 1, the square root of 1 is 1. The square root of 2 is some decimal 1.4 something. The square root of 3 is 1.7. If I go to square root of 4, I'm up at 2. Okay, I'm going to go like this. Now, if I try to plot numbers over here, plug in numbers for x to the left, if I plug in -1 or -2 or -4, a real number does not come out of this. We talked domain back in 2.1, maybe earlier on in the chapter. We talked about domains and restrictions. If I have a square root, square roots only spit out real numbers if the stuff underneath is non-negative. So there is no picture, there is no part of the graph, no part of the function that's defined to the left of the y-axis. The domain of this function are numbers from 0 to infinity, starting with 0. Okay, our range is the same way. The lowest point on our graph is 0. There is no highest point. There will be some other functions that are shown, graphs that are drawn by your author in the book. These are the main ones that I would like for you to make sure that you know and recognize. Okay, and we will play and move around and work with these as we do the transformations and other things in other sections. So let me know if you have any questions.